Hello, I'm Carlos Rosas and this is CRS channel. This is the third video on physics problems dealing with kinematics, specifically motion in one dimension. So we'll go back to this problem here. We were going to analyze the part for points A1 and B1. TA1 is between TA and TB. YA1 is between Y0 and H. TB1 is between TB and TC. It is between V0 over G and 2V0 over G, as A1 is between 0 and V0 over G. YB1 is between H and Y0. And YA1 equals YB1 equals Y with this curl on the left. Y is then between Y0 and H. Okay, so using this expression here, we're going to find T for A1 and B1. So we have, passing all this over to the side, taking square roots on both sides, remembering that G0 plus V0 squared over 2G is H. We have that T equals V0 over G plus minus the square root of 2 over G times H minus Y curled. Okay, the plus sign corresponds to TB1, the minus sign corresponds to TA1. You can see that in time, TA1 is equally separated from TB as TB1 is from TB. Now, having that TA1 equals TB minus delta T and TB1 equals TB plus delta T, now we can proceed to calculate VA1 and VB1. So, replacing this value in the equation for velocity VA1, we have V0 minus GTA1 equals VA1, and after replacements and simplifications, we have that VA1 equals the square root of 2G times H minus Y. Okay, making the same replacements for VB1 in the respective equation, VB1 equals V0 minus GTB1. You get that VB1 equals minus the square root of 2G times H minus Y. So, we have that VA1, VB1 have the same magnitude but opposite directions. So, for any 2 points with altitudes between those altitudes corresponding to the initial altitude y0 and the maximum, which is h, if they are equally apart from in time from the corresponding time which the ball reaches the maximum height, they will have equal speeds, only that one will be moving upwards and the other one will be moving downwards. That is, if they have the same vertical position, that is, if they are at the same height, then they will be equally separated in time with respect to the time of the ball reaching the highest altitude. Now we can go and analyze the case of point D. Point D is between points C and E. We have that Vd equals V0 minus G times Td. Then we have Td equals V0 minus Vd over G. We place this expression in the expression for Yd, which is this. Do the respective math, and after replacing V0 with this value here, remembering that since h equals y0 plus V0 squared times over 2g, and we know that V0 equals the square root of 2g times difference h minus y0. Oh, replacing this expression in this equation here, we obtain for Vd this expression here. Vd equals minus square root of 2g times h minus yd. Now replacing both the expressions, the one for V0 and this for Vd, in this expression here, we get that Td equals the square root of 2 over g times the difference h minus y0 plus the square root of 2 over g times the difference of h minus yd. As for point E of the diagram, you have that at point E, the ball has reached the ground, so that y equals 0. Okay, doing the same that we did for point D, we have Te equals V0 minus Ve over G, as we had Dd equals V0 minus Vd over G. And Ye, which is 0, would be equal then to Y0 plus V0 times this expression, which is this, minus 1/2 of G times this expression, which is T squared. Doing the math and simplifying, remembering that V0 is the square root of this, we get that V equals minus the square root of 2gh. Now if y would be different from 0, we'd have this difference, but since y is 0, we simply have 2gh in the radical. Okay, so replacing this and replacing the value for V0 in this equation, we get that T equals this radical, which corresponds to V0 over G, plus this radical here, which corresponds to minus Vg. Okay, so now we go to consider what happens after the ball bounces back from the ground. The equations for motion of the ball are for the velocity v equals ve prime minus g times t minus te. Now here our reference of time changes from 0 to te, which is the time which the ball hits the ground, and ve prime is the speed, the initial speed when the ball bounces back from the ground. Since h prime is less than h, then we can assume that ve prime is less than ve. So it will be less than square root of 2gh. Okay, so y equals then ve prime times t minus te minus 1/2 of g t minus te squared. Okay, so first thing we have to do is find what's the value of t of ve prime. That we can do by considering the case when the ball reaches the new height h prime at the time t prime. So at that instance, the velocity will be 0, and then we have 0 equals v prime minus g times t prime minus t. So t prime minus t will be v prime over g, and h prime will be equal to, that means when y equals h prime, ve prime times ve prime over g, which is t prime minus te, minus 1/2 of g v prime over g squared. That'll give us v prime squared over 2g, which leaves us with ve prime equals square root of 2gh prime. T prime will be then equal to te plus v prime over g, and we'll get this, which is this. We replace te here, and we get this expression for t prime. Okay, so from here we can go on to consider what happens for points F and G. That will be done in the next video.